Sketch a graph of the piecewise defined function. Be sure to include closed or open dots, but only at breaks in the graph. Then find the domain and range of the function, and be sure to answer in interval notation. Let's start with the graph of this piecewise function. So in order to graph a piecewise function, as long as you're comfortable with graphing functions in general, especially lines and constant functions, which are just horizontal lines, and restricting those to individual domains, then this shouldn't be much of an issue. So the graphs that we have here, 2x minus 3, generally what I would do is I would start off by figuring out where on this boundary at positive 2, because there's kind of this separation right here between these two pieces of functions. And on this interval back here, where x is less than or equal to 2, I'm going to graph 2x minus 3. And on this side, I'm going to graph negative x plus 2. So I need to figure out where on my graph things are at this boundary. So I'm going to take 2 times 2 minus 3, and then I'm going to take negative 2 plus 2 and evaluate each of these. So this gives me 4 minus 3, which is 1, so that's at the point, 2, 1. And this becomes 0, so this is the point 2, 0. Now, this point is less than or equal to 2, so this one's included, so I'll use a closed circle here, but an open circle here. Okay, so let me get rid of that, and let's do this. So 2, 1, closed circle, and 2, 0, and open circle. All right, now from here, in order to graph a line, all you need is a point on the line and what its slope is. And if you, generally you're starting with the y-intercept, and that's great, but the y-intercept isn't necessarily on your graph any longer. So that's why I'm using these boundary points instead. All right, so on this interval where x is less than 2, I have a slope of positive 2. Now, a slope of positive 2 can be thought of as a rise of 2 and a run of 1, or as a rise of negative 2 and a run of negative 1. Either one of these result in the value 2, which is the same slope. So what I'm going to do is I'm going to go from this point, I'm going to go down 2 and back 1. Down 2 and back 1. And just get a couple of points over here on this interval. And then for the other side of the line, I have a slope of negative 1, which is the same thing as going down 1 and over 1, down 1 and over 1, and I get plenty of points over here on this interval. So that's how we graph it. Now, to input it into the homework system, we have the different tool sets here available to us. I would start with the points. So closed circle, what did we say, 2, 1? And then the open circle here was at 2, 0. And use array because these lines are going to infinity. So we're starting here. We have a slope of 2. And then we started at this point and we have a slope of negative 1. Now don't worry about these red circles looking like they have filled in your open circles. They haven't. If you click on them, you'll see that they haven't. All right, now the last thing is to identify the domain and range. So the domain is all the x values that you can put in here and that have some sort of y value that correspond to it. In this particular case, the domain is all real numbers. So what we would enter here is the set from negative infinity, and here you can just put 2 lowercase o's, and that will interpret infinity, that's fine, to positive infinity, and then close parentheses. The range, the function is only defined down here up until this point right here at 1, and then there's nothing for the function up in this region. So the range is only from negative infinity to 1. So we'll say parentheses negative infinity to 1, but there's a closed circle there at 1, so I'm going to include that point. So that's the range of my function. And there we go.